I don't think everyone who loses their job because of an AI will sort of become an AI developer suddenly, because the gap is just too big. So government needs to be thinking about how to address this. And even if some people don't like that transformation, it will happen anyway. If we don't do it here in Germany, China will do it. So we should be at the forefront of that transformation and support people in finding new jobs, becoming entrepreneurs, for example. We should be thinking about meaningful retraining and really help those people to take advantage of their potential.
I very much agree. And if I may add, I think it's not just training them with real skills, but helping them to find what they care about and how they want to make a contribution. I really think that pretty much all jobs that are plainly, you show up and basically, you're doing something mechanical or that doesn't involve your human capacity will be high on the list of being replaced. So no matter how many low level jobs we are able to create right now, they're not rewarding for the workers personally, and they're only short term.
So when I talk to companies, I see one problem. A lot of companies start and say that they want to do AI now. And I think this is just a wrong approach, because they come with a solution and often they keep creating problems that actually don't exist. So my view is different. We should just do it the opposite way around. We should be wondering, what are our problems, business problems. Maybe some processes are very expensive, maybe they take a lot of time, maybe they come with uncertainty. Maybe there are certain things so far we have just not been able to do at all in that company. And then we should solve them as easy as we could. AI may be the solution, but AI is not necessarily the solution.
You don't have the classic conference announcement, here is the new thing, and then the next day it's available all over the world, right? That's exactly what you should not do, because what matters in AI is context. Every use case, every use context makes a huge difference. And so what you do with AI-based products is you introduce them in a small community somewhere where ideally, if it goes wrong, it's not spreading, and it's somewhat contained and you can understand what happened. Then you do that a couple of times in different communities, and then you roll it out, and you're always ready to make adjustments based on the feedback that you get from certain use cases. And that's truly fascinating. And I think that's next to the efficiency gains and all the other benefits. It really challenges us to rethink how we do things in a meaningful way, and I quite like that. Welcome to 42X. My name is Max Senges. I'm leading the charge for 42 in Wolfsburg. And today I am together with a great guest who I only met recently, but I'm quite impressed. His name is Patrick Glauner. He's a professor here in Germany for AI, but has been educated in a number of different places and has been in industry. I introduce him in a moment a little more. We met about a week ago after we got, I guess, recommended to each other. And I'm very much looking forward to have a conversation with him about artificial intelligence and how to learn it, and what we may or may not do to get to a good outcome when it comes to the trajectory, how AI will influence our daily lives, our societies, politics, and economics. Hi, Patrick, really cool that you could join us today.
Hi, thanks for having me on the podcast.
Totally. So I give a little bit more background on you, just so that folks can place you in their minds, but you'll also get the chance to correct me or extend what I'm saying. Um, Patrick is a full professor for artificial intelligence at Deggendorf Institute of Technology. He became that role. He got that role when he was just 30, so amazingly quick for academic standards. And he also did an MBA while he was doing his PhD. So clearly very motivated, and I think in that sense, a good candidate for the 42 mindset, because our students are also pursuing the learning goals because they have the intention to go through and do it in their own pace, in their own organization, not to make a professor happy. And I think that mindset is really important, and we'll get to that when we speak more about learning, about machine learning and AI. He's also the founder and CEO of Skyrocket AI. I would assume that this is basically your way to bring your expertise to the private sector, but you're welcome to give a plug on what Skyrocket AI, the consulting service, does. He's written several books, in fact, two in 2021 alone, creating innovation spaces and digitization in healthcare with Springer Publishing, and then one last year, innovative technologies for market leadership in 2022. Really quite impressive how you pull all of that up. Maybe we should have a conversation about time management too, because that certainly is a lot on your plate. Please feel invited to introduce yourself and complement what I just said, Patrick.
Yeah, thanks for the quick intro. So I'm Patrick. I'm a professor of AI at Deggendorf Institute of Technology in Bavaria, Germany. I also run my own AI consulting company, Skyrocket AI, on the side. So I help companies with AI strategies, with implementations. I offer workshops and all of that. I advise small and mid-sized companies, but also some of the largest companies in Germany, and also work together with some of their board members. I really like the real world link when it comes to AI, because I think there's a huge gap between academia and the real world. And I aim to bridge that gap both through my teaching and my research, as well as my consulting. I studied in Germany, where I did my bachelor's. I did my master's at Imperial College London. And yeah, you mentioned I did my MBA and PhD in parallel. One of the coolest places I worked in the past is CERN, the European Organization for Nuclear Research. So spent 3 years there and worked on AI, which was a lot of fun. But now I'm very happy as a professor, because the professorship comes with plenty of freedom, and I'm really free in choosing what I teach and how I teach it and what I work on.
That's a very good explanation. I'm glad you added that last bit, because I agree. The freedom you have to decide what you do in your job is an enormous factor in how satisfying the experience is. And frankly, I'm a little worried that with all these efficiency gains and all this transparency, the last minutes of the worker gets optimized, and I'm sure the history of that started with Taylorism, really looking at people standing at a conveyor belt and optimizing kind of by the seconds, how each step of the value creation can be made quicker. And I'm at 42. We're really interested in developing a mindset that is conductive for learning and for working in the digital age. And as I'm sure you agree or have a perspective on, when it comes to coding, when it comes to delivering highly complex knowledge products, you cannot optimize by the minute. In fact, maybe you have to go for a walk for 2 hours and enjoy nature, and then sit down and look at a problem again, and that's when you take it to the next level. So really different dynamics. The pace of how you work, how you sequence things are really important. So yeah, certainly the freedom, a good aspect. Now, traditionally in this podcast, we allow our guests to define the first question, kind of to open the floor with their key messages. And in your case, the question was, how do you teach AI? And it's a great question. Can you please share with us how you do that?
Yeah, so I think if you look at most courses on AI at universities all around the globe, there's a very strong focus on methodology, like how a neural network works, how decision trees work, how tree models work. And all of that is important, but it would not really help you to just know that in order to deliver value. Because in a lot of settings, it doesn't really matter whether you use a neural network or a decision tree. Obviously, there are some cases, like in some computer vision problems, for example. But for most problems, it doesn't matter too much. Rather, what happens in practice is a lot of companies, they start building prototypes, they do feasibility studies, and then they get stuck. But what we actually need is that we need to turn this into something concrete that adds financial value. And that's what I approach in my teaching. So I teach some courses that focus a lot on methodology, like my computer vision course. But I also want students to build something that works at the end of the course. So maybe to do a robot vision project or build an app. So something that really works and is not just like a model that runs maybe for some test data, but I want them to work it in the real world. And I also teach a course on AI innovation management. So, innovation management for AI, where I help my students to bridge the gap between the theory and business. Because finally, AI experts also need to know about innovation management. They need to know how to pitch certain ideas to managers. They need to know how organization works. They need to know about budgets. And if they don't know that kind of stuff, they will finally just get stuck with prototypes that don't add anything. And I think a lot of other universities should work like this too. I mean, theory, yes, that's important, but you also need to know how to turn the theory into products and products that finally add financial value. And I think most universities so far have not done that transition yet. There's still a huge gap, and but there's a huge demand for experts on the market, but there is only a demand for experts who really know how to add value. And that's why I think universities will face more and more pressure in the next years if they don't address that issue.
That's a really good perspective. Let me challenge you on one aspect, and maybe you just compressed it, but you stressed the financial value. Um, uh, these days, more and more organizations and leaders are considering triple bottom line and thinking that it's not just about the monetary value that's created, but also the social and the environmental, which are more difficult to measure, of course, and our system is more optimized for the financial. But is that something that has come up in the conversations you have with industry and your students?
Yeah, so finally we can generalize this maybe to something that we call add value, financial, but whatever. But finally we have to add some kind of value, and rather if we just build prototypes that don't lead to products, we have a problem because we invested a lot, but we don't get anything in return. So yeah, aside from purely financial aspects, it can also be about well-being. Maybe we can allow employees to reduce working hours because maybe the AI does part of their work. So what I mean in general is maybe not just financial value, but value, and then it's up to you and your business problem how you would define value.
I like that a lot. Now, the first question that I thought about when I prepared for our conversation was really to understand your perspective on what benefits and challenges are really there when it comes to AI and machine learning. Um, I think you already pointed out it's a general problem when you think about kind of code monkeys, right? Just implementing something. You can spend a lot of time and money working on AI problems, and frankly, also making progress. But the big question is always, what for, right? What are the achievements that we can realize when we advance AI and machine learning, and how do we maybe hatch some of the risks and manage to focus that we get more benefits than negative effects?
So when I talk to companies, I see one problem. A lot of companies start and say that they want to do AI now. And I think this is just a wrong approach because they come with a solution and often they keep creating problems that actually don't exist. So my view is different. We should just do it the opposite way around. We should be wondering what are our problems, business problems. Maybe some processes are very expensive, maybe they take a lot of time, maybe they come with uncertainty. Maybe there are certain things so far we have just not been able to do at all in that company. And then we should solve them as easy as we could. AI may be the solution, but AI is not necessarily the solution. Imagine you have an overly complex business process with a lot of step mutual dependencies. Well, the AI will not really get you anywhere. Rather, you should rethink that business process, so use your human intelligence first, and then you use the AI to improve it further. But if it just doesn't work because it's too complex, AI will rarely help you. So I think we should always solve problems as easy as we can do. AI may help. Sometimes maybe it's just a few rules or rethinking something. Then obviously there are plenty of challenges when you want to work on AI, like you need enough data, you need to aggregate data from different sources, you have issues with your data quality. So there are plenty of things that can happen, obviously. But I think what a company should do first, um, solve one use case very quickly. Um, we don't like this in science because it's the low hanging fruit. We don't like that in science, but in industry you should do it because like this you can really show value to your stakeholders, to your managers, and then they are also more willing to invest more. But rather, if it just takes you years for your code monkeys to try something that doesn't work, you won't convince anyone. That's why have quick results, demonstrate that something works, add value, and then typically you'll get more budget to continue with this. Then obviously you need a data strategy, an AI strategy, because you don't just want hundreds of use cases to be solved in parallel. Rather, you want to have a common or a mutual infrastructure. You want to share data with others, and you don't want to reinvent the wheel all the time. Maybe you can reuse certain parts for other use cases. That's something you need to think about later, obviously.
Good point. I will dig a little deeper and ask you about the black box factor in AI and how you recommend stakeholders to address that and to manage around that. But I did want to very quickly mention that your point about the low hanging fruit, I think that's true for traditional academia, right? And the research side of it. I think that now we're moving to a more transdisciplinary world where a lot of different expertise and different stakeholders come together when they tackle a problem, right? So just from the very practical point of, um, you create a new team, you want to get into a new field, it makes total sense to me to start with something fairly easy, and not just to prove to your manager that you can do it, but to learn in your group, in your team, how to actually do get some processes, get some rhythm, get the trust between people going. And it's been good practice in the hacker community, in the software community, open source community, to not come in and have a grand vision how to realign the kernel production, right?
Mhm.
But to do a quick bug fix, get to know others in the community, and that way you dive more in. That's exactly how our students are learning. Now, one aspect that I hear over and over again is that we never really know how the neural net, how the machine learning is actually performing what it considers. It's very difficult to look inside the black box. The terms like explainable AI that I think are really important, to be honest, from my perspective, more for trust building with the end user than for the expert systems, but also for the experts. I think it is a challenge to understand how to manipulate, how to um, shape the solution in a way. Next to the fact that obviously you need to clean the data, and the data needs to be, is what causes your system to work in one way or another. Please, could you elaborate a little on your view on the black box paradox?
Yeah, so quite a lot of machine learning models are considered black box models. So they make decisions and you don't really know why they made this decision. So there has been a call for explainable AI. So you can explain how these models work, why they make decisions. Sometimes it's called explainable AI, sometimes it's called interpretable AI, whatever, and there are plenty of other terms. Um, but there are models already that you can explain, like a decision tree, for example. You can just visualize it. But if you take a very large decision tree, or you take a random forest, so which is a collection of a lot of decision trees, well, that is explainable already. Does anyone understand what it does? I don't think so, because it's just a very large model. So with neural networks, sometimes you can visualize why they make certain decisions, but I don't think explainable AI will be the solution to a lot of the current problems. I don't think so, because a lot of things around us are not explainable. A lot of doctors, human experts, they make decisions and they don't know why. And if we required explainable AI in a lot of AI applications, I think we would just get stuck. If we required full explainability in medicine, we wouldn't have most of our medicine today. But in medicine, what you do is testing. You have trials. So you make statistical tests, and then you can draw an inference of how good your medicine is or not. And I think testing is key to most of our AI problems. Explainable AI, it may help in certain cases, but I don't think it will be the solution to most of the problems. Rather, we need better testing. And then we can say, well, we can, and we don't just use an accuracy and we say we're right in 99% of the cases. Rather, we use proper statistical tests. And these kind of things have been used for the last 100 years or so, also particularly in medicine and in a lot of other safety critical applications. And that's what we need. There's even some research about explainable AI, and that research found out that once you make your model more transparent, it actually becomes more difficult to find certain mistakes that it makes, because there's an illusion that the transparency would be great, and then people don't really look at it anymore. So I personally think we need more testing to solve a lot of the current challenges and to create trust. And that's what we do in plenty of other fields too. If you look at the European Union, in April, they created a proposal on regulating AI all over the European Union. Maybe you follow this. And I looked into it, and governments are now looking into it, because if ratified, this would have a huge impact on AI all over Europe, or all over the European Union. And the European Affairs Committees of the German Federal Parliament and the French National Assembly, they organized a joint session last month in May, and they invited experts in order to testify on this, or give oral evidence on the EU proposal. And I was invited as one of the experts, and I gave oral evidence, and I explained that the EU proposal, if ratified, would largely kill AI innovation all over Europe. And I think the people who wrote it, they don't know that much about AI. So it's mainly lawyers and policymakers. But you already need to start with, how do you define AI? What's AI? And if you look at the proposal, they say that it includes everything that includes statistics. So any kind of statistical method is now AI. So if you just calculate the mean of numbers in a software, you suddenly have an AI, and you're covered by this regulation. So I don't think this will really help us. And I think what we need is testing in safety critical applications, not explainable AI. If explainable AI helps, yeah, you can do it. But if you just look at a very large random forest, yeah, you can explain it. But will it help you anything? I don't think so, because it's just too big.
So thanks, really cool pointer also to the policy discussion and to the challenge that there is it's understood that AI is very powerful, and hence lawyers and policymakers rightly want to understand and want to get a handle on it. But as is always the case with paradigm shifting technologies, and this is a paradigm shift, right? For me, the example is always, we used to live in a Newtonian world and basically have very literature like Swiss watch, mechanical watch like systems where you had system calls, and it was all in a deterministic environment, and that's not the case anymore. It's kind of like moving into a complexity science world where a program is more like the weather. Yes, you can understand how weather patterns are moving, but each individual case might be different, and so you need a different way to assert what's going on. I think there's two aspects of explainable AI. One is, okay, let's have people, almost like an AI literacy, understand what this is about, right? So that they can generally understand that this is not magic, and that it's following clear rules. For example, like you can put hard limits at points, like if the result is lower than 20, just don't feed the result out, and thereby you basically control that no severe harm is being done, right? That
Yeah.
these old mechanisms still function, while other predictability aspects might not. That said, the other aspect of explainable AI is, in the case something goes wrong, how can you open up the hood and really look and understand what went wrong, so that you can take measures so that it doesn't happen again? And that's the part that I think is more tricky and not easy to implement. But you're a much deeper expert in this. One point I wanted to mention, as you said, testing is the key bit. When I was working at Google, and we were discussing policy changes and changes when we are moving to a more AI-based product world. The insight was that you don't have the classic conference announcement, here is the new thing, and then the next day it's available all over the world, right? That's exactly what you should not do, because what matters in AI is context. Every use case, every use context makes a huge difference. And so what you do with AI-based products is you introduce them in a small community somewhere where ideally, if it goes wrong, it's not spreading, and it's somewhat contained and you can understand what happened. Then you do that a couple of times in different communities, and then you roll it out, and you're always ready to make adjustments based on the feedback that you get from certain use cases. And that's truly fascinating, and I think that's next to the efficiency gains and all the other benefits. It really challenges us to rethink how we do things in a meaningful way, and I quite like that. So, little bit of a hard segue, but we've been talking about the potential of AI. You actually mentioned what you care about when you teach AI, but I want to invite you to help us think a bit about how to help our 42 students. And remember, there's no professors, there's no lectures. How we help our 42 students to wrap their head around and become machine learning AI practitioners. So we usually start with kind of a hello world exercise. Then you program tic-tac-toe, then you program Tetris, and then you program a chess computer, right? Like that's more on a high level how we approach things. Do you think that is even possible? And if yes, what should we consider as we're developing materials in that field?
Well, for AI, there's plenty of material online or online already. Like you look at platforms like Udacity, Coursera, and plenty of others. There's already so much out there, and it's very hands-on. So don't reinvent the wheel. If you can integrate such things into your learning, you should do it. Uh, when you become a practitioner, obviously you also have to know state-of-the-art libraries like TensorFlow, Keras, whatever. But make sure you also understand the theory, because these high-level libraries, they're very easy to use and they work great when it works, but sometimes things don't work. And then you should know why it doesn't work. So you should know the theory, and you should also know the theory. So simply, if there's a new library, say Keras gets replaced by something different, that would put you out of business if you only know the library. So you should also understand what's going on under the hood, so you can easily transition to other libraries, to newer libraries, and it will simply help you to fix problems when your models don't work. So this is what you should pay attention to. Do real stuff. So become a practitioner, know the theory, collaborate with companies, work on real challenges. I think that would be great, because a lot of the learning materials online, they are great, but often they're just about academic data sets like MNIST and Titanic data set, whatever. But once you work with real data from industry, there will be plenty of new challenges.
And there's challenges in following your recommendation, because of course having the data set ready by the time the company is at a point where they have understood, you mentioned data strategies, right, where they have understood what data they have, how to prepare it, how to be able to share it. These are pretty significant steps that I think that there is a lot of collaboration and thinking together needed between stakeholders as we move into that world. Now, as you know, we are based in Wolfsburg, and Wolfsburg is one of Germany's mobility slash automotive hubs. Um, and I personally believe it's super helpful to think 10 years, however long, like far into the future, because once you have a conversation about that and you find a common goal, the differences that you have today might look much smaller than if you get together and you say, oh, but we are different companies in the same field. We're competing. No, we're actually pursuing a joint goal. I personally, for example, believe that interoperability and security are fields that can benefit significantly from open standards, open source work that is beautiful in the sense that once you put it out, you can benefit from collaborations with academia, with smaller partners, right? Smaller partners feel more on eye height with big partners. It's a much more leveled playing field, and let's figure this out together. I have worked on internet governance and these open standards type work for a number of years in the Google context. And what I always felt was very positive was at a place like the Internet Engineering Task Force, where really literally the next generation internet is being prepared for the last 40 years. And, arguably they've done a pretty good job in expanding that network, right? There is no membership. There's no membership fees. There's no conditions to join the meetings. But what they have established is a culture that when you go there, you actually hang your company affiliation at the door and you have a real engineering, a rational conversation with as little politics and business considerations as possible. You're really looking at how to move the subject forward. And I think that would be really interesting, just to give you a sense of, that's kind of my shtick when I think about what would mobility look like in 10, 20 years. Uh, do you have a perspective on how AI will influence how we move about, how logistics are working? Some thoughts in this direction that we can move towards.
Well, I see this as a very positive development because if you look at Germany, still 3,000 people die every year in traffic. So if we have autonomous cars, this will certainly go down. People will still die, that will still happen, but it will drop a lot. And I think that will help us. Probably we also need less cars than we got right now. So maybe some of the automotive companies don't like to hear this, but they need to come up with new business models because if you look at a family, often they have two cars because one of the adults needs to go to work in the morning. Maybe the other adult will drive the kids to school or kindergarten. But most of the day, you don't use those cars. So maybe you just get one car, an autonomous car. It will drive you to work, then return, and then it will drive your kids to school. So obviously, the automotive companies will not like this. But when it comes to sustainability and resources that we need, I think that's certainly something or a direction we need to explore, and it will certainly be happening. So I see a lot of potential here, but it's not just autonomous driving. Generally, logistics, maybe even autonomous ships. If you look at cargo ships, they spend quite a lot of money on the crew that spends months on these ships. So it needs a lot of space. You need a lot of water, food, and other resources. But if you have an autonomous cargo ship, well, certainly we will all benefit because the costs will go down and it will also be more sustainable. So I think there's a lot of potential, and we already start to see this now with autonomous driving. And if you just look back 1 or 2 weeks ago, German Parliament passed a new law, so you can explore those topics now far better in Germany. And if you look at Volkswagen, they've started to invest a lot in software and AI. So I think that's great, and I hope the other automotive companies in Germany will do it similarly in the coming years, so they can move ahead with AI and digitalization. So I think it's a very exciting future, and I'm excited to see what will happen.
That's cool. I like your optimism. Let me nail you on one point that I'm sure, as an AI researcher, you're confronted with all the time. So, you've mentioned uh, less people on a boat. We need less cars, so probably also less people will work in car production, right? Smarter our systems get, the less people we need. I question mark. And if that's not the case, what do we need the people for? Let me do a quick plug. I actually helped to edit this book, Disrupting Unemployment, that's thinking exactly about that question of how is it possible that we're wasting so much human potential by having people unemployed, basically not participating in the value creation. I think it's a real sad stage that we are already in, that we're not able to provide more work and meaningful engagements for people. But it's also not there are a couple of answers, and it's not an obvious question. So, what's your take on it?
Well, ever since the beginning of the Industrial Revolution, jobs have changed and jobs have disappeared. If you just look back 100 years ago, most of the jobs from that time, they don't exist anymore. And but what has happened over the last 250 years is we have become richer, healthier, we live longer, we have better jobs. So overall prosperity went up, and AI will or has started to disrupt the market in a similar way. But if you just look back 250 years ago, a farmer maybe became a factory worker. So people have changed jobs. So we need to be even thinking more about continuous education, lifelong learning, and all of those things. But I do wonder, I don't think everyone who loses their job because of an AI will sort of become an AI developer suddenly, because The gap is just too big. So government needs to be thinking about how to address this. But I think if we do it right, it will certainly improve our prosperity. And even if some people don't like that transformation, it will happen anyway. If we don't do it here in Germany, China will do it. So we should be at the forefront of that transformation and support people in finding new jobs, becoming entrepreneurs, for example. We should be thinking about meaningful retraining, especially in Germany. If you look at unemployment, there isn't much of a motivation to help those people to find new jobs. Rather, they get sent to the same boring training 20 or 30 times, and they learn 20 or 30 times how to write a CV, which obviously doesn't get them anywhere. So I think we need more meaningful training, and really help those people to take advantage of their potential.
I very much agree. And if I may add, I think it's not just training them with real skills, but helping them to find what they care about and how they want to make a contribution. I really think that pretty much all jobs that are plainly, you show up and basically, you're doing something mechanical or that doesn't involve your human capacity will be high on the list of being replaced. So no matter how many low level jobs we are able to create right now, they're not rewarding for the workers personally, and they're only short term. So I'd much rather see people, as you said, in an entrepreneurial fashion, picking up beekeeping in the city, right, and being happy being a beekeeper and maybe not making enormous amounts of money, but doing something that they love and that's meaningful for them, than to create 1,000 jobs building an autobahn or whatever
Yeah.
short-term measure you might have, where it's work where maybe some people like it, but most people are really feeling that it's a chore, that they're going there, and their real life starts when the work stops. I'm sure you and I don't even feel that we're working because we're working on stuff that is interesting and meaningful to us. So I never look at the time, how much did I work today.
Yes.
That's a different section. So really cool. I'm looking forward to dive deeper in the future. But today, I would like to close our conversation by asking you for a couple of recommendations to our listeners who don't know. We are building a manual for happy software engineers, which is basically a library that will contain 1,000 books, and it will only be 1,000 books that cover the technology, but also the organizational stuff and the personal development and personality character developments that you want to think about as you're practicing software engineering and you're becoming a 42 student and learner and an adept. So I know you've thought about a couple of books that you'd recommend us to include in the library, and by looking at them, I'm quite confident they make a good addition to the library. Please, can you share your first book?
So the first book is Artificial Intelligence: A Modern Approach, published by Stuart Russell and Peter Norvig. This book is now available in its fourth edition. So the book has been around for the last 20 years or something like this, and just recently the fourth edition has appeared. I think it's a fantastic book because it provides a very broad perspective on AI, both machine learning as well as some of more of the traditional approaches. And that book is up to date now in its fourth edition. And if you want to learn about AI, take a look at it. You can also learn about the history of AI and some early things. So I think it provides a very, very good perspective. And if you just look at the second or third edition, a lot of the statements they made in there are still valid today after 10 or 15 years. So I think it has a very, or it is durable for quite a long time. The second book is
Hang on,
yes.
sorry. Let me quickly get a plug in here. Of course, Peter Norvig has been with Google, as has Russell, I believe. I don't know him too much, but I've hung out with Peter Norvig quite a bit. And one kind of subset is a paper he wrote together with Alon Halevy and Fernando Pereira on the unreasonable effectiveness of data. And there is a nice talk that he gave that you find on YouTube with the same title that really nails this point about why is everybody talking about data being so important for the future developments, and what qualities of the data actually matter, and why scale is so incredibly important that for this type of learning. So I think it's a really good pointer, great choice. Please share your next book.
Well, talking about Peter Norvig, so there are a lot of books out there that you should definitely not add to your library, like books like Learn Programming in 10 Days or something like this. And if you look at Peter's website, there's a parody or like to this, and it's something like Learn Programming in 10 Years, in which he argues why it takes so long to learn programming. And I think that he has a really cool website with plenty of interesting things on it. um, yeah. And the second book is Pattern Recognition and Machine Learning, published by Christopher Bishop. So the book appeared, I think, more than 10 years ago. So it doesn't cover recent deep learning advances. Nonetheless, it provides an excellent introduction to machine learning and covers a lot of its statistical foundations in depth. And most of the things in there are still usable today. As I said, the deep learning things obviously have not been reflected in this book. Nonetheless, it's one of my favorite books on machine learning because it discusses the statistical foundations extremely well. What I see among professors, there are professors like myself who really love this book, and others hate it. Some feel it's extremely complex because Christopher Bishop is a physicist, so he assumes that you know a lot about mathematics. Once I saw the website of a professor, I think from MIT or Stanford, I don't know, and he even wrote on his website he does not recommend that book because he would not understand most of the book either. So it has mixed reviews. They're either really good or really bad. But if you like mathematics and you want to learn about the foundations of AI or machine learning, you should definitely read this book.
Cool. And as I would recommend all of us, actually, sometimes it's also cool to read stuff that's way above your head, right? Not I don't know if this is your practice as well. Certainly, in my trade in philosophy, if you pick up Sein und Zeit, and you start to try to grasp what Heidegger wants to say, you're probably going to fail, right? And failing in understanding a book is not a bad thing. In fact, I almost see it a bit like going to a museum or going to a zoo. Not everything you see in a museum or in a zoo is going to excite you and is going to be a memorable experience. But every time you go, there's this one thing, right? This one piece of art or the one animal that is in a particularly interesting mood and doing something interesting. So you don't go to grasp it all and to find everything exciting, but to move your to grow your understanding bit by bit, and you never know basically. And so I always find pieces that are really difficult particularly interesting, because come back to them, or at least they point a problem that you will think about for months, possibly years, as you just pointed out. Humans are actually not super fast learners when it comes to these questions of mastery and highly complex topics.
Well, I fully agree. The Bischoff book is exactly that kind of book. So I've been using it for 10 years or so, but there are still certain sections and certain equations and derivations that I still have not understood. And but each time I look in that book, I learn something new, and it's certainly, I think, very helpful. But I do understand that a lot of people struggle with it, myself included, that there are some sections that I just don't get. But overall, I learned a lot from this book.
I just because I think it's actually funny in a deep way of how we deal with this non-understanding and how sometimes uh, even things that you might not agree or that doesn't really make sense, that don't really make sense, can be helpful on the path to understanding. I wrote a paper on identity with Dirk Becker, who is one of the leading sociologists in Germany of the Niklas Luhmann school. Right, so system thinking, which is super complex. And at one point in the paper, he started to write down a formula, and it was super complex, and I asked him questions, and he explained, and I was like, but da, da, da. And then at one point I was like, okay, I think I get it. But then I asked another question, and you know what he said? He said, sometimes you have to let it go and just leave it at this point, because they're not stable. These functions, if you look at them again, you might want to write them slightly differently, and you don't agree. So it's more like you're documenting where you are, or you're having an object that you can reassemble and think about. So it's a think piece. It's tools for thought along those lines, rather than having the ultimate answer. That would be, of course, 42. But what does that help you if you get 42? You need the tools. You need to understand and think about why you get there. So great chatting with you, Patrick. If there's anything you want to plug, or any last thought you have, you're welcome to do so. Otherwise, it's my turn to say a big Dankeschön, and I hope to see you again soon, maybe sometime in Wolfsburg, or if you come to Berlin, you're also welcome to get in touch, and let's see if we can get together in real space.
Thank you very much. Looking forward to talking more in the future, and I'll definitely visit you guys sometime in the future.
Cool. Cheers.